Hey YouTube, welcome back. Today we design a key value store. Today we have basically we're trying to answer a real world system design interview question. Each question of the questions that we're trying to solve in the future, we will divide it in 4 videos. Basically, we have a framework to go in any system design interview. I don't know where is this framework. I guess I did delete it. Okay, so let's talk about this one. So, in terms of system design interview, um, when your interviewer asks you about a specific question, it doesn't basically means that you to design a full key value store because it's a pretty complicated component and you have only 45 minutes in the interview, so you will not, of course, it's not possible to design the full key value store. It's basically your interviewer needs you to ask clarification questions and know what exactly the in your interviewer head so you to design. So in this one, when you have been asked to design a specific system, the first thing that you need to know is that what is this system and what specific problem does this system solve, because otherwise you'll not be able to solve this problem. So a key value store is a type of non-relational database that stores data as a collection of key pairs where a key serves as a unique identifier to access its corresponding value. This model provides a straightforward and efficient way to store and retrieve data. And why we need a key value store? It's basically for the simplicity and speed, like key value stores offer a simple data model and are optimized for speed, particularly for retrieval operation, making them ideal for applications that require quick access to large amount of data. It's also great when it comes to scalability. So they can scale out horizontally, meaning you can add more servers easily to handle more data for or more client requests, which is essential for high traffic application. Also, we have high performance. So due to their simple structure, key value stores can handle high load and deliver high performance. They often provide constant complexity, often for data access. Also, it's great when it comes to flexibility, so they allow for more storage of various types of data, such as string, lists, or sets, without needing a predefined schema. This is flexible, is beneficial for applications with involving data models. Also, the distributed nature. So, many key value stores are designed to be distributed across multiple nodes, improving fault tolerance and availability. They support application and partition strategies that enhance resilience and performance. So we did talk right now about what is a key value store and why we need it, and this is the first step in your system design review. You need to know what are we designing and why we need this one. After that, we have to follow a specific framework that is sequenced from 4 steps. The first step is to understand the problem. The second step um, is to establish like a high level design of your design or of your system. The third step is to take a deep dive in your on your components, on a specific component. And the fourth thing is to wrap up. And in the wrap up also you can discuss some improvements of the system. So we have a four step process or 4 step framework that will help us to be successful and organized in our system design interview. So let's talk about the idea of understanding the problem. So understanding the problem and establish design scope. Basically, your primary goal is to gather as much information as possible to clearly understand what you are expected to build and what constraints you need to consider. This step is crucial because a clear understanding of requirements and constraints ensure that you design a system that meets the user's needs and expectations. So we see right now our goal in this step, and this step, in my opinion, it's the most important step in any systems and interview. We need to gather the information to clearly understand what you are expected to be built, and this will take us. Sorry, I got a phone call. So this will put us into this list that you can see right now. And these are the topics that we mostly ask about in any system design interview. Basically, we have the functionality, scalability, and performance. We have functionality, scalability, and performance, data model, and consistency and availability, durability and reliability, and operation controls and security. Let's try to think about all of them. Let's see that first we want to ask some questions about functionality. So first we might think about, okay, what are the core operations that the key value stores needs to support? For example, get, set, delete, etc. Maybe you could ask other one like, are there any additional features required, such as support for transactions or path operations? If you are using a lot of SQL databases, you understand what I'm talking about. You need to ask about scale and performance. So, for example, you ask yourself about what is expected scale in terms of numbers. What are the expected scale? What is the expected scale in terms of number of keys, value size, and request rates? What are the latency requirements for read and write operations? What is the read vs write load distribution? Do we need expect more read operations or write operations? This is in terms of the scale performance. For example, we want to ask about data model. What types of values will we store? Are they simple strings, binary props, or complex structures? If you want to ask about consistency and availability, and this is big one, basically we ask what level of data consistency is required. Is feature consistency acceptable? How critical is systems availability? Do we need to design it available? Durability and reliability. We say, okay, should data be persistent? If so, how durable should the storage against crashes or data loss? Or how should the system handle node failure or network partitions? If we want to talk about some operations concerns, like do we need the ability to monitor and manage systems performance and health in real time? Are there requirements or for backup and restore processes? In terms of security, what level of security is required? Do we need authentication and authorization, for example? So just put this list in your head. We have a seven section or seven topics that we always ask about in any system design interview to clearly understand what are we designing. So let's look at a real example of like a dialogue between you and the interviewer. So let's say that we want to ask about the functionality. So we say, okay, to start, could you clarify the primary functionalities that our key value store needs to support? For this one, he will say, or she, sure, the key value store should support basic operations such as get, set, and delete. Additionally, it would be beneficial if it could handle bulk operations for efficiency. The second one, we want to ask about the scale and performance. So I say, okay, understood. Regarding the scale, we are designing for what are the expected request rates for these operations, and do we need to have anticipated asset size? So our interviewers say, okay, we expect the system to handle up to 1 million requests per second at peak times. The dataset should support up to 10 billion key value store with values up to 10 kilobyte in size. So I would say, okay, let's say KB. I write this one wrong. So okay, that's quite a scale. We ask about the functionality a scale, and we want to ask about the performance. So moving to performance requirement, what are the expected latency they're showed for these read and write operations? Like we aimed for read operations to complete within 2 milliseconds and write operations within 5 milliseconds. So currently also I know right now we need our system to be pretty fast in read operations. I will ask the other question. I will say, got it. How about the distribution between read and write operations? Do we anticipate a read heavy or write heavy workload? I guess this question is useless because from this question we know that it's a read heavy system. So I say, okay, I see regarding the consistency. Can you specify whether eventual consistency is acceptable or do we need to ensure strong consistency? I would say eventual consistency is acceptable, but we need to minimize inconsistency window. So we accept eventual consistency. So in your head, suddenly we are maximizing the availability. So for availability, how critical it is that the service remains operational and what is acceptable downtime. So high availability is crucial, and the system should design to be achieved 4 nines uptime, minimizing downtime to least possible. And the last question it will be on the topic of durability. How should the system handle node failures or persistence or data persistence? So we say okay, data should persist and resilience to node failures. We expect the system to recover automatically from individual node failures without loss. So I guess you don't need to ask more than that. It's 7 questions. And basically, you need to ask from 6 to 10 questions. And you find yourself, you only ask about these topics. This framework will make everything quite easily for you. Right now, I highly recommend you to stop the video and try to write the requirements from this diagram and watch it over and over. So let's talk about the requirements here. So from this one, we have first the functional requirements. It's a pretty simple. We need to create a database that supports read and write operations. So we will focus here on the non-functional requirement. So the non-functional requirement starts first with the size of key value pair is small, is less than 10K or up to 10K. We want ability to store big data because we said that we have 10 billion key value pairs. We have the system is high availability. The system responds quickly even during failures. We said that in this one, the answer of our interviewer. Also, we have also high scalability. The system can scale to support large data set. And we said that into this one, we have 1 million requests per second. We have automatic scaling. The additional deletion of service should automatic based on traffic. We have tunable consistency, and in this one, we have it from our interviewer here. We have low latency because we have a read and write ratio 1. We have 2 milliseconds and 5 milliseconds, so we have low latency. And this is how you gather the requirements. So if your requirements look more like my requirements, just share them in the comment section. I will review them. And if they are, maybe you add more 2, 3 points that I forgot to add, just put them in the comments also. I really learned from that. And in this step or in this video, we just asked the first question, and we gathered all the information that needed for this step. So that's it for today's interview. That's today for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you don't miss a video. And see you in future.